The following simulation is to be used with the forces of motion data collection and processing activity that is found on the student Google site. This simulation contains many different activities, and these are shown in the tabs above. However, for this data collection and processing activity, we're going to use one activity, which is the friction tab, where we can see that there is a simulation that contains a wooden crate on a horizontal surface, and when a force is applied to the crate will move either left or right. The purpose of this investigation is to look at the relationship between the reaction force of the crate, the normal force, here in yellow, and the maximum friction force, when the crate is undergoing constant velocity and agreeing with Newton's first law of motion. At the moment, there's no friction force because there's no applied force, but we'll get to that later. Underneath the simulation, you'll see that there are 5 sliders that we have control over. The first slider we're going to manipulate is the gravity slider. This sets the gravitational field of the simulation. At the moment, it's set at 9.8 meters per second squared, the value of gravity on Earth. However, to keep the maths a bit simple, we're going to change this to 10. If you have a little bit of a problem trying to get this to 10, you can actually manually type in the number and then it will be set. Once you've set the gravity slider to 10 meters per second squared, you don't need to touch this slider at all, and we're going to keep this constant. Above the gravity slider is the object mass. The object mass in this investigation is the independent variable. That is, that it is the variable that you have control over. If I increase and decrease the object mass, you can see that the blue line, the force due to gravity, and the yellow line, the normal force, increase and decrease proportionally. Therefore, we can assume that they are equal and opposite, constant and agreeing with Newton's first law of motion. If you read through the student instruction sheet, you'll see that you're asked to select the object mass to specific values. This can be done using the slider. However, once you've set those values, you can see their numerical value over here, and object mass can therefore be recorded using suitable error. Above the object mass are 2 quantities called static and kinetic friction. For this investigation, we're not going to differentiate between the two. We're just going to call them coefficient of friction. Therefore, at any point during the investigation, we must assume, or we must set, both of these frictions to be the same. That is, that the numerical value stated here in the right hand side, both of them must agree. Throughout the investigation, you'll be asked to change the coefficient of friction. If you change the coefficient of friction, you must change these two equally, so that at all times these 2 numerical values agree. Your teacher, after you've done this data collection and processing activity, may go back to this simulation, and you could use this simulation to differentiate between the 2 types of friction. However, for this investigation, we're going to assume them to be the same, so we don't have to worry about that. Other things that we have control over in this investigation are the free body diagram, the vectors, the walls, and the position of the box. For the free body diagram, we're going to select it to be shown. You'll see that the normal force and gravity force appear in the free body diagram, and they look exactly the same, or they look exactly the same as the box below. The free body diagram will actually help us to see the applied forces and friction forces easier when we start to manipulate the applied force below. The other thing we're going to do is in vectors, we're going to click the sum of the forces. This is the sum of the forces between the forward force and the friction force. At the moment, those are not shown, we'll get back to those. We're going to keep the walls brick, we're not interested in this, and we can move the box either left or right. And personally, I like the box to be at the left. The last thing that we have control over in this simulation is the applied force. The applied force in this activity, or in this data collection and processing activity, is the dependent variable. The applied force depends upon the normal force, which depends upon the object mass. If I start to apply a force to the box, you'll see that Fa starts to increase, and Ff, which is the friction force, also increases. At some point, you'll also see there's an F sum force, and the box starts to accelerate to the right. Whilst you've done this, you'll see that there is a playback function recorded below. If I repeat the playback function, I can first of all select the playback function to be normal, slow or fast, and if I repeat the recording, you'll see that it's recorded of what I've just done. You can see the applied force here, you can see the friction force here, and you can see another quantity called the F sum, which is the difference between the 2 forces, the applied force and the friction force. For this investigation, we actually want to record the friction force, or the maximum friction force, applied to the object. That'll be the force just as the object starts to move along the horizontal surface. To make sure that we get an exact friction force, we need the friction force and the forward force to be equal and opposite, agreeing with Newton's first law of motion. Therefore, for the object to move across the surface at constant velocity, there doesn't, or there should not be, any F-sum force. To do this, we're going to reset the object to the left. I'm going to clear the recording, and I'm going to start to apply the force. As soon as I apply the force, forward force Fa and friction force also start to increase. At some point, you'll see that F-sum appears. If I then track my applied force back a little bit, you see that it will disappear and the object starts to move at a steady constant velocity. If I pause the playback function and I play back what I've just gone and done, you will see up in the free body diagram here that at some point my forward sum force, or my F-sum force, starts to appear, and then when I've pushed back the applied force a little bit, you'll see that it disappears, and now we have an applied force of 237.31 newtons. That means that the applied force is 237.31 newtons, and because the object is going at constant velocity, we can assume the friction force to be the same. Therefore, we have the maximum friction force that is being applied to the crate. One last thing in this investigation that you need to be careful about is that the applied force is sensitive to 1/100th of a newton. However, the applied force lever isn't as sensitive as this numerical value states, and you're going to need to play around with this a little bit to find a suitable possible error for the applied force whilst completing this simulation. All you have to do now is go back to the Google site, download the student instruction sheet, and use this simulation to complete the data collection and processing activity for this simulation. Thank you.